This is the sequel you've all been waiting for. No, not T2, one of the best sequels ever, but Scientific Notation, Part 2. Today, we're going to be looking at adding and subtracting with scientific notation. Let's get at it.
So Terminator 2, I'm not too sure how many have actually seen it. It was fantastic. I love the soundtrack to it. And one thing that I really appreciated was the technology that got advanced in the movie. If you see the guy that transforms shapes, that was groundbreaking back in the day when I was your age, watching that, and it was absolutely very cool. Now it's kind of taken for granted, that kind of stuff. So go check it out. Highly recommend it. Today we're looking at adding and subtracting, scientific notation, but we have to remember a couple of things. The first thing we have to remember is our rules for moving the decimal for scientific notation. So remember, scientific notation is always to the base 10. So for this one right here, I'm just going to show you a couple different things. If I want to go and move my decimal to the left, so I just want to go and do this. Let's say I'm kind of bored today and I want to go and do that. So I'm going to do that. So now my new number is, I always like to put a 0 here. So 0.425. When I do that, what do I have to do to the actual base 10? So what's going to happen here? I have to go, and I'm going to have to go and add 1 to the base 10. So my, our final answer here would be, if I wanted to do this, is 0.425 times 10 to the 8th power. Now, let's say I wanted to go and just move it the other way, just for fun. Say I wanted to do that. So now I would have the number of 42.5 times 10 to the 7th. And what's going to happen there is I'd have to go and subtract 1. So I'd have a number of 42.5 times 10 to the 6th. Okay, so we're going to use the idea of moving the decimals around and altering our base 10 exponents when we're talking about adding and subtracting scientific notation. So here we go. There's basically kind of the go-to rule. So here's our rule that you're perhaps taking notes on, is when you are adding and subtracting, you need something. You need the same base 10 exponent. So we're going to use what we just saw to sort of do that. So let's go an example, and then you'll be like, oh, so that's what he's talking about. I get it. Well, this is actually first start off nice and easy. Let's say you had 5 times 10 to the 5th plus 3 times 10 to the 5th. Okay, well, you got to go and ask yourself, we're adding here. So is our base 10 to the same exponent? They're both times 10 to the 5th, so yes, they are. So basically, you end up getting 5 plus 3. So we're going to take this 5 and this 3. We're going to add them together and times it by 10 to the 5th. So that's just going to be 8 times 10 to the 5th. Now, if we're talking about common kid mistakes, so the KKM, what are the common kid mistakes for this one? Well, one is kids remember something about adding things together. So they're like, okay, so 5 plus 3, I get that, 8. But some kids then go and add 5 plus 5. They actually go and they add the exponents together, and they make this not 5, they make it times 10 to the 10th. No. This is all adding 10 to the 5th stuff. So there's 5 10 to the 5ths, and there are 3 10 to the 5ths. So there are 8 10 to the 5ths. So you don't go and add all the different exponents. That's one of the common kid mistakes. The other one is forgetting the rule that they have to have the exact same base 10 exponent. So that's kind of the big things to kind of keep in mind as we look at some more examples. So let's go take a look at a few more where we're going to have to go and use some of our knowledge and skills and understandings And here we go. Let's start off with this one. 4 times 10 to the 6th plus 3 times 10 to the 5th. So right away, you're kind of looking at the base tens, and you're saying they're not the same. And your little spidey senses kind of go off. Your little spidey senses. So you guys know Spider-Man, right? How do you draw Spider-Man? I'm not very good at drawing Spider-Man. Speaking of sequels, is it like Spider-Man? Does he go this way? Is that how his mask goes? Spider-Man, there's some great sequels right there. I'm excited about the new Spider-Man coming out. That looks excellent, especially after the Avengers cameo. So how are we going to go and change this? The rule. So we'll say this is Spidey's rule. So Spidey's rule is change the smaller exponent. So change the smaller one. So we're going to go and look at the exponents. So 6 and 5, which number is smaller? You're going to say 5. And because 5 is going to be smaller, we're going to go and change that to 6. So that's what we're going to go and do. So how would I go and change that? So remember, this is 3. I'm going to put down 3.0 times 10 to the 5th. And I want to go and change this exponent so it becomes to the 6th. So in order to do that, I have to move this to the left. And when I do that, what do I have to do over here? I have to add 1. So my final kind of number is now going to be 0.3 times 10 to the 6th. And don't forget, we had 4 times 10 to the 6th. So now we're going to go and just kind of combine, add our 4 plus 0.3, and we still have our 10 to the 6th. Nothing has changed now. Now they're the same base 10, so we can just go and add those together. So now what we're going to eventually get is this, that's pretty easy to add. 4.3 times 10 to 6. Not too bad. So kind of remember the Spidey's rule there. That is very, very helpful. What else we got? Let's try this one. 9.1 times 10 to the negative 4. Ooh, negative exponents. Plus 1.7 times 10 to the negative 3. Okay, so remembering Spidey's rule, you have to go and change the smaller exponent. So let's go and change the smaller exponent. Now, remember, what's the smallest number? Negative 4, negative 3. It's going to be negative 4. Negative 4 is going to be smaller. So again, I kind of want to show what's going to happen here. I'm going to go and I need to basically add 1. I need to add 1 to this. And in order to do that, I need to move the decimal to the left. So you really got to be comfortable about which way the decimal kind of works for that one. So now I'm going to have 0.91 times 10 to the negative 3 plus 1.7 times 10 to the negative 3. So now I can go and combine kind of those coefficients out in front. So I can go and combine those now. 1.7 plus 0.91 is going to be 2.61. And they're still at times 10 to the negative 3. So there you go. So really get used to moving those exponents around and seeing how all that kind of works. Does that sound pretty good to you? Do you need to see some more? Do you want to see one more? I guess we can show one more. It's not going to hurt, right? It's not going to be painful. I've never seen anybody get hurt by seeing another example. So we got 6.8 times 10 to the negative 9 plus 9 times 10 to the negative 7. Okay, so again, you're looking at your exponents, you're saying, I want to kind of go and move the smaller one, so I want to change this negative 9. So in order to do that, I need to add 2, just like that. And I have to add 2. That means I need to move my decimal 1, 2 over, just like that. So now I'm going to have 0.068 times 10 to the negative 7 plus 9 times 10 to the negative 7. So I'm just going to go and add all that up. So the reason that you move that smaller one is because it makes your adding and subtracting so much easier. So you get 9.068 times 10 to the negative 7. And there you go. Adding and subtracting with the same base exponents. So remember, don't forget about the common kid mistakes and sequels. Shoot off some comments. What are your favorite sequels? Maybe you're a huge fan of Finding Dory, the sequel to Nemo. Maybe you liked the second Lord of the Rings. Who knows? Write down in the comments or shoot me an email, and let's get on to the challenge.
Now, some people might argue the best sequel was actually Empire Strikes Back, which is ironic because it is episode 5. But let's ignore that and let's get into some word problems and some complicated scientific notation for the challenge section. Here we go.
So Empire, obviously the best sequel ever. Perhaps one of those movie moments where the cliffhanger, I'm not going to spoil it, the cliffhanger, I'm not too sure if you get the same experience out of that nowadays with all the information that everybody knows about the Star Wars universe. I know I'm trying to shelter my child from finding out about the cliffhanger, and we'll see what happens. It should be kind of interesting to see if it's the same kind of reaction that I had, where I could not believe it at the end of episode 5. It was unfathomable. There's no way that could actually happen. And if you don't know what I'm talking about, you got to go watch the whole trilogy, 4, 5, and 6. So today we're looking at some challenging scientific notation. Hopefully you've taken a look at the past video. So we had stuff with, you have to have some information on multiplying and dividing, scientific notation. So I always like to call it kind of sci-naught. And you also have to make sure that you know the rules for adding and subtracting. Scientific notation. So this won't make any sense if you don't have any of those ones. So remember, for this one, you basically had to make sure that you're multiplying the stuff outside together. So there's like times 10 to the 5th. And you're multiplying this by, 3.1 times 10 to the 12th. You're multiplying those things together. And then you're multiplying these together. And you're actually, because you're multiplying the bases together, you're adding the exponents. And for adding and subtracting, you just saw that. I mean, you can rewind this video, actually, right? And for this one, you needed to have the same base exponents. So that little x had to be the same for both of them. Then you go and add and subtract them. So those are the big takeaways. So let's just jump into it, shall we? Yes. Let's just jump right into it. Here we go. Let's have 8 times 10 to the negative 4 plus, we'll start with the adding stuff, 1 times 10 to the negative 5 all over 5 times 10 to the 6 minus 5 times 10 to the 5th. So right away, when you see this kind of question, if I'm a student, I'm like, wow, there's a lot of things going on. And just go slow. I like to always kind of emphasize that, you just deal with the top part first, right? Deal with that part first, and then go and deal with the bottom. And then at the very end, just go and divide. So it's like you have 3 different questions going on here. So don't get freaked out. You can do 3 questions. We know that. So let's get rid of those little circles and let's start doing it. So let's deal with the top part first. And so we're adding here. So we're adding. So you know that to add, you need to have the base 10 exponents the same. And they are not the same. So we're going to go and I'm going to make the smaller number become the same exponent. So I'm going to have to add 1 there, which means I need to move this decimal 1 place over there. So you end up getting, I'll kind of go a little bit slow. This is 8 times 10 to the negative 4 still. And now it's 0.1 times 10 to the, we change that to negative 4. So now I can just go and add these together, which is really nice. So I get 8.1 times 10 to the negative 4. So that's the top part. Now, we need to get the bottom part done. So for the bottom part here, I'm just going to go over there. Again, we need to have the same exponents. So I'm going to go and increase. I'm going to go and increase what we're doing for this one. So that's going to be basically, actually maybe I'll go and change it up a little bit. Should I go and change it up? Yeah, I might go and actually change this one up. Yeah, I'll go change it up. So I'll move this one. So I'll move this one here. So there's my little decimal. So I'm going to move that over there, which means I'm going to add 1 to this. So now we're to the base 6s. So this is, what I was debating about is how I wanted to go and do this. So this is 5 times 10 to the 6th minus 0.5 times 10 to the 6th. So I can see maybe a mistake happening here, but this is going to be 5 minus a half. So now it's going to be 4.5. So we're going to get 4.5, and we're still at times 10 to the 6th. Okay, so again, this is like 1 question, 2 questions, and now you have a 3rd question. So here's our next question, is if I had to go and divide this. So you got your calculator out, of course, right? You got your calculator. So you have to go and basically go and divide this. So what's 8.1 divided by 4.5? And of course, in your calculator, you're going to get 1.8, just like that. Awesome. And then you're going to go and you're going to divide this. So when you divide your same bases, you have to subtract. So this is like saying minus 4 minus 6, which is minus 10. So your final answer is 1.8 times 10 to the negative 10. Always check to make sure that your answer is in scientific notation. It is, because it's 1 digit and then the decimal. So it's all good. And we didn't make any kind of silly mistakes with our subtracting numbers here. So it looked kind of scary, but it's not. It's basically 3 separate questions and using all of your scientific notation knowledge and skills. Excellent job. Let's take a look at one that just involves some multiplying. So for this one, 2 times 10 to the negative 5th. And, sometimes you'll see these in brackets, like that. Times 6 times 10 to the 7th. All divided by 4 times 10 to the negative 8. So this is a lot of multiplying and dividing. So we're going to do the stuff on top first. So we're going to do, all of this stuff here first. And that means that these numbers multiply. And these numbers multiply. So 2 times 6 is just going to give me, so that's going to give me like 12 times 10 to the, we're going to add our exponents. So that's going to be 10 to the 2nd. And we're going to be over 4 times that 10 to the negative 8. So here we're going to have to go and do our dividing. So 12 divided by 4, so that's 3. And we have to go and divide these. So, I could see this being perhaps, a little bit tricky. A little bit tricky there. Because when you're dividing, what are you doing to your exponents? You are, of course, subtracting them. So this is really saying 2 minus 8, which is times 10 to the 10th. Just like that. So kind of be careful there. That was maybe the tricky part right there. And there's your final answer. Is it in scientific notation form? It is. And everything is nice and happy. So you're going to see kind of those complicated ones. And of course, we would be remiss if we didn't have some word problems. So how much farther from the sun is Saturn than Earth? So that's interesting. So that hopefully your solar system stuff, that the Earth, of course, is a little bit closer to the sun. But I want to know the difference between them. So Earth is basically this far away, and Saturn is this far away. So hopefully you're saying to yourself, gee, what do I need to do? I need to do some subtracting. And again, I really do hate this program that I'm using to do this. This should be times 10 to the 7th. And this is not 108. This is 10 to the 8th. Like that. Okay? So I want to know the difference. So the difference means subtract. So basically this question is 9.3 times 10 to the 7th minus 8.87 times 10 to the 8th. Now, again, we're going to go and have to change our exponents so they are the same. So I want to go and add one to this, the smaller one. When I do that, this goes whoop over there. You don't have to use a sound effect, but I like using the sound effect. So this is now 0.93 times 10 to the 8th minus 8.87 times 10 to the 8th. So now we can just go and do our math. So that's what you're basically going to be going and doing right there. So we're going to go and do that. When I end up doing that, what ends up happening, you end up getting, it was at 7.94, I believe. I think if I use my calculator here, 7.94, something like that. And we still have times 10 to the 8th because these are going to be the same things, like that. So that is the difference between them. And there you go. So hopefully you got some little practice with some harder questions for scientific notation. And you have two basically lessons on this kind of stuff. So hopefully you have a good grasp of the scientific notation. Thanks a lot, and check out some sequels. No, actually, just 1 second. Let's skip back here. I'm just kind of taking a look at this. It must be early morning recording of this kind of stuff. So I went and did this. In my head, I was doing this differently than actually what I just showed you, didn't I? Did anybody notice, I guess, the the teacher mistake, the teacher common mistake, I guess, the TKM, is what did it go on subtract? I actually did this kind of this backwards a little bit. And I wonder if a kid would actually do this. They might. So maybe we need a diagram here. Actually, I don't use that color. Let's start from scratch. So here's the sun. There's the sun, and the Earth is here, right? This is the Earth, and then there's Saturn. So there's like Mars, and there's Saturn. So like Saturn has those rings around it. There's my Saturn, right? So obviously, I think Saturn is actually bigger than the Earth. But anyways, so Saturn's there. And if Saturn is this far away and Earth is this far away, it's actually the other way around. So these are flipped because I should be subtracting the farther away one, shouldn't I? So it's this one, so this distance, and take away this distance. And I did it the opposite way there. And this is why I was probably just like looking at the numbers going like la 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 la. And I said, oh, 9.3 is bigger than 8.87. Well, here's a fun thing. Which one is bigger? Obviously, 9.3 is bigger. But if it's times 10 to the 7th or times 10 to the 8th, it makes a huge difference, doesn't it? So, 9.3 times 10 to the 7th is actually smaller than 8.87 times 10 to the 8th because that 10 to the 8th is so much powerful. The exponents have a lot of power, so it's another base 10. So actually, when you go and you do this one, and stick with me here, let's go to the correct color of green. It's really like 8.87 times 10 to the 8th minus 9.3 times 10 to the 7th. Okay, so that's actually what is happening. And eventually, when you went and changed your exponents, it ended up being 8.87 times 10 to the 8th minus 0.93 times 10 to the 8th. So that's where I was getting 7.94 times 10 to the 8th. In my head, I was just doing that. But obviously, when I was writing it down, I was not writing down what exactly was in my head. Has that been clear now? All right. Saturday morning recordings. This is what happens. So hopefully that kind of clears that up for everybody. Okay, so big takeaways. Make sure you're being clear, especially when you're showing your work. Make sure you have watched the trilogy of Star Wars 4, 5, and 6. And don't get too shocked by the end of episode 5. Don't worry, everything works out nicely. And hopefully this has all been as clear as mud. Till next time.
Thanks for tuning in, everybody. Hopefully you've gotten a good grasp of scientific notation. You can always go back and check out part 1. And don't forget, subscribe. Click the button.